Lovely. Well, listen, first of all, thanks, Alan, for inviting me to have this discussion. I really wanted to share some thoughts about the developing nature of 5G. I think, most folks within the telecom industry, certainly at the onset of 5G, kind of really welcomed it with a lot of enthusiasm, and the de facto posture is that this is something that's going to kind of solve a lot of the world's needs. The reality of it has been somewhat underwhelming, and certainly kind of the visions of the private cellular market developing, and the low latency network slicing capabilities that were meant to be ushered in on the wave of 5G deployments, haven't really manifested yet. And so I thought what would be helpful is to maybe try to rationalize some of it, and give first a little bit of a brief history of cellular. I'm going to use North America as kind of the example here, but I think it's indicative of other places globally. We'll talk a little bit about this notion of 5G being kind of an enterprise-driven type of technology, and talk a little through why that's not really been the case in terms of adoption, certainly. And then I wanted to share a model, Carlota Perez model for prediction in terms of how can we start to anticipate where the road may actually wind. And then talk through a couple of candidate use cases that I think if we do some double clicks on, we can kind of right size our expectations. So if we go to the next slide, just very quickly, looking back to look forward. I've tried to give a fairly simplistic outline of different cellular generations from 3G to 4G to 5G. I find it particularly illustrative to look at each of these technologies through the lens of its business model. Namely, what value is being created, what value is being delivered, how are different actors capturing value from it, and what was the reality of the marketplace at the time. Certainly with 3G, when it came out in 2001, it was really about connecting people and places. Most of us wielded the power of 3G through our feature phones, and we had voice, SMS, and data. The value that was captured was really your subscription. The interesting piece here is the market. So when 3G was deployed in North America, over the course of 5 years, they added 111 million subs. There wasn't any smartphone penetration back then. There was no real smartphones. But over the course of 5 years, another $5 was added in terms of the average revenue per user. A bit of an anachronistic term now that most people are using ARR, but I find it useful to kind of understand, what was the growth in terms of revenues over the 3G era. But 4G had a similar profile. It started to, usher in a new wave of technology around applications in video. The smartphone appeared. This iconic iPhone suddenly hits the market in 2007, a couple of years prior to the deployment of 4G. And really the name of the game for a lot of the carriers were around data plans and monetizing the increase in data usage that resulted from the higher bandwidths. Important again to kind of double click on this market. So in North America, again, there would be another 50 million subscribers added across the US. Smartphone penetration was pretty low. It was going to grow up to 93%. We're fully saturated as an industry. But also importantly, there was another $5 per sub added to the ARPU. So that brings us to 5G. And when we look at 5G, there's a lot of question marks as to what is the value being created. Is it fixed wireless access? Certainly, we're seeing a lot of that being deployed. Is it Industry 4.0? There is the capabilities that come with ultra reliable, low latency communications and massive machine type communications. Is it the metaverse? Certainly, there's some crashing expectations around the reality of the metaverse and the ability to achieve some of the response times and latencies that come with the combination of 5G and edge. But we haven't really centered on what the value creation is. what is the value delivered? Is it going to be through an edge compute, or is it going to be a network slice? Are we capturing value through bundles? None of this is really kind of settled laws yet. I think as we take a look across the globe, there's various kind of kind of plays being mounted, and whether or not any of them turn out to be entirely successful, it's difficult to say. Most carriers are in let's keep our subscribers and reduce churn, so 5G tends to be a little bit of a hygiene thing. Not many are experiencing some dramatic new experience as a result of it. But importantly, taking a look at this market again, 5G relative to 4G and 3G really comes at a time when the economic climate and opportunity for growth is somewhat flat. There's not a lot of new subscribers to acquire, particularly in the developed economies. Smartphone penetration in the US is very, very high. The ARPU trend is slightly up, but it's mainly flat. So the question is what's this return going to be on 5G? Where is it going to come from? But certainly the table is not set for the type of growth that we've seen in prior generations. So if we go to the next slide. The answer for a lot of people was, well, it's these enterprise features. When we bring in capabilities like network slicing, we bring in ultra reliable low latency, massive machine type communications, the classic 5G triangle that we always talked about. We've really only seen the enhanced mobile broadband dimension of 5G, not these other two corners of the triangle. And really, those other two corners are meant to address enterprise. And we've heard a lot about the viability of this particular industry segment. Having been in telecom for the past 30 years, there's been a lot of starts and stops, starting with things like small cells, and then as we've kind of grown through the industry, we haven't really seen dramatic uplift in terms of this. And so the question is why? Certainly the forecasts are saying it could be a fairly significant market, somewhere around 12 billion. There's some intuition across a lot of the different marketing reports that you see out there that number is underrepresented or understated. But no one's really kind of pierced the veil of what are the issues, and there's a number of them. Some of them are around cost per square foot relative to let's say Wi-Fi. To deploy cellular, it's somewhere on the order of 75 cents to $1.10 per square foot, whereas Wi-Fi sits closer to around 20 cents per square foot. Integration, most cellular systems were developed for large carriers who have massive operations. They're not really right-sized for an enterprise environment. Namely, you can't take things out of your AAA LDAP policies and inject those to configure your cellular network. They require some high-touch administration. Just the complexity. You're dealing with, in some cases, kind of a public network interaction where you have near-far effects, and you have to negotiate that with the wireless network engineering team of a large carrier. That can be pretty outsized competition for a small enterprise. The IR41s, if you're needing to do roaming, can be difficult to negotiate. Kind of just justifying who's going to pay for the equipment is a dance that seems to take on epic proportions in some cases. Finally, when you look at the notions of substitutes and control, there are viable alternatives. Wi-Fi evolving to Wi-Fi 6E and Wi-Fi 6 and Wi-Fi 7, are all taking on greater and greater capabilities in terms of multiple access capabilities, in terms of wider bandwidths, in terms of higher densities that can be supported. So, the question is 5G really going to be able to kind of meet some of these niche needs within the enterprise? The great white hope is still that there's some interaction capability between 5G and Wi-Fi, and that a certain percentage of use cases, particularly when it comes to latency sensitive, I'm thinking robotics or campus-wide mobility, those types of use cases, may start ringing the bell of 5G, but are people willing to pay a premium for that? And what's the return relative to the economic need within a particular enterprise? There is evidence that that there are legitimate reasons to do this. Certainly in the auto manufacturing industry, which is highly roboticized, when you have AGVs that are traversing huge square footage, having the ability to have kind of controlled mobility in a network architecture that supports it, proves to be valuable. Simply because the outage within a manufacturing facility for automobiles can accumulate costs pretty precipitously, and so the return that you get from having a mobile infrastructure like cellular can pay for itself within a year. The ultra reliable low latency is another significant capability in terms of outage and availability, particularly if you're able to hit the heights of a bit error rate of 10 to the -9 or -12. That can be an appreciable difference, and certainly the latency aspect, when you can get a guarantee within the scheduled space of a 5G system, are also advantages, and they do open up new opportunities. But we're not seeing those really being deployed as headlines across these private spaces. It's simply because most of those services aren't available today. You don't have ultra reliable low latency. You don't have network slicing. These are very complex features. In many cases, they start to break some of the advantages you get from cellular. So there is a lot to be said. There is I think some emerging practices. If we go to the next slide, I think the dominant pole is really around this notion of cost. And if we're able to start to understand how do we get the cost to be right sized for an enterprise, particularly given that it could be 3 to 4x the cost of a typical Wi-Fi deployment. If you look at these different deployment models that are kind of listed here, there's two that are fairly traditional. One is you get the mobile service operator to provision in-building services or campus services for a particular enterprise. You can be decapitated from the overall public network and just be standalone, where the enterprise owns the infrastructure. But the one that's really emerging, that seems to be getting a lot of traction, particularly with the emergence of lightly licensed spectrum like CBRS in the US, and obviously other geographies have picked up similar types of spectrum as a function of their regulatory bodies, is this neutral host, this ability to have spectrum that can be shared across multiple operators. And why is this helping us to address cost? It's really applying the principle of operating leverage to the enterprise space. By intermediating the operator, you also abstract a lot of the complexity that an operator brings to the equation. You open up the opportunity for policy to be driven by the enterprise and by the operator in kind of a dual policy model, just simply because there's an intermediated agent. But when you come back to this cost equation, it really does start to reveal the benefits of neutral host, and the massive difference between let's say a Wi-Fi deployment and a cellular deployment tends to be the packet core subscription costs. The radio costs are relatively equivalent between Wi-Fi and, for instance, a CBRS radio. And in some cases, just simply because of the network nature of cellular, you can usually get away with fewer radios. So it's not the radio cost that dominates, it's really the cost of the core and the SAS provisioning for CBRS, for the dynamic frequency sharing, as well as any type of SIM management and back office activity that has to occur around the core infrastructure for cellular. When you amortize that across multiple enterprises through a neutral host, there's a break-even point. Usually comes in and around your 10th customer, where the cost suddenly craters to be equivalent to that of Wi-Fi. So you can imagine a reality. Certainly this is not a vision that's radical. It's a vision that we've been talking about for a while, where these little micro operators start to appear, who are neutral hosts, who can do interconnects with other operators and provide the public roaming, but also provide the management and operating leverage required to reduce the cost per user or per enterprise for deploying cellular services. So this is a model that I think has some legs. That I think the issue is just simply we don't have large scale neutral host providers today. There are some that are emerging, and you see over the course of the past year or so, a few of them have fallen. A few new ones have started to appear, but the scale is still pretty limited. And it's the scale operation that we're looking to see if the industry can achieve. I think the table will be set when we kind of truly get this kind of running at full tilt. So if we go to the next slide. So I did want to have a kind of a quick thought around what are some of these applications and when can they come, and how should we actually start to tease our head around the reality of 5G? And I like the Carlota Perez innovation model, for those who aren't familiar with it. She describes a kind of a view as to how technology diffuses through a particular society. And writ large, Carlota talks about this as technology revolutions that span 30-year increments. You could equally compact that down and look at it through the lens of cellular. And you can see there's kind of two different phases. I've noticed that these tend to be fairly predictable across any generational change in cellular technologies, where you have an installation phase where there's kind of rapid growth. You're building out the coverage networks for 5G. A lot of the funding for it is debt being raised by the mobile operators. And for the most part, the return is largely based on speculation. And believe it or not, there wasn't a lot of understanding about what the killer apps or what the revenue growth profile was going to look like for 3G and or for LTE. But they come over time. And what happens is there's a turning point in the industry. This is where profit pools tend to shift. Companies in the network equipment space, for instance, suddenly disappeared. We lost Nortel, and Lucent got consumed by other larger players. You have service providers who consolidate or expand and diversify. Sprint and T-Mobile both joining in the U.S. and then the appearance of new operators like Dish. So you typically have a turning point in the industry that happens after around 5 years. So we haven't hit the turning point. We're still in this upswing. There's then a deployment phase, and this is the golden age. This is where steady growth occurs. We've been able to anticipate kind of some of the applications that are rooted in traction within the enterprise community or within the consumer community. And that traction has yielded some profits. Those profits help to fund new production capital to be deployed for building out additional capacity in the network. And you get to a point where the technology matures and we get capacity exhaustion, and now we need a new spectrally efficient protocol so that we can kind of satisfy the growing demand. That's typically the profile. And so, just as a way of framing the discussion, we haven't hit the turning point as yet. We're a couple of years away from it. We're still in this early phase, and so we're in the speculative phase of trying to understand what is the reality of 5G going to look like. So let me nominate a couple of candidates, and I think the seeds for where it could go are here today. They're always present in the present. But it's trying to understand how are they going to extrapolate into this golden age. So if we go to the next slide, Alan, thank you. I'm going to give you 3 examples, and we're going to quickly cruise through some of the logic for it. going to talk about industrial automation, which is going to be largely delivered through these twin capabilities of ultra reliable, low latency, and enhanced machine type communications. We're going to talk about the digital divide and how things like 3GPP, NTN, or non-terrestrial networks is starting to usher that in and give a solution for it. So we're moving towards an era of planetary coverage, which is very exciting. And then I'm going to talk about, the poster child that everybody likes to speculate about. It's, the AR, VR, mixed reality, cloud gaming. A lot of these are rooted in infrastructure delivered by 5G through edge data centers and things like network slicing. I kind of gave a few, predictions about commercial timing, but, quite frankly, it's always dangerous to make a prediction, so I'd hate to be held accountable for these dates. These are kind of opinionated commercial timing. So if we go to the next slide, let's just talk about industrial automation for 2 seconds. The IFR kind of publishes the amount of robots that are shipped in a given year, and this was a banner year. They've had a peak shipment of robots into the automotive industry and non-automotive. The thing to look at in order to understand, well, where are things going is, take a look at the geographies where the density of robots are the highest. And those tend to be, areas like Germany, Japan, Korea, tend to have high industrial automation, largely delivered on the back of, the automotive industry, but very quickly it's catching up in the electronic component industry as well. So what I've shown here is a view about industrial robot density, average across the world, per 10,000 workers, and then I took a look at the best. So this would be areas like Japan and Germany, and so you can see that there's a potential here where the rest of the world can catch up. I took a look also at the auto industry and the non-auto industry. You can see that the auto industry is heavily roboticized. Whereas the non-auto is really just fledgling. So while the diffusion of robotics is, definitely here, it's uneven. It's uneven across geographies and it's uneven across industries. Also kind of pull in machine vision, in particular robotic vision and 3D vision in industrial settings. Again, you can see that in certain areas like Japan, companies like Keyence have been dominant in the 3D robotic vision industry. There's some heavy density of deployments, whereas the rest of the world we have yet to catch up. So what this shows, and it tells a tale of, is that just with the technology that we've got today on the ground, there is 4x to 10x potential in terms of densifying robotics across industries, across geographies. I also put a little view here of the industrial IoT and digital twin space. There's companies like Fanuc who are the world's leader in robotic deployments. They have their own common control platforms. There's this called Field. They work with Rockwell, and with that common control, they're able to connect a lot of the robots and create greater and greater efficiencies in terms of industrializing a lot of different factories. We are seeing these deployments, really take root. Companies like Siemens with MindSphere are also, looking to get into the common control and the IoT digital twin space. This is a real thing. It is, very markety to talk about them, but when we take a look at deployments, there is a fairly steep trajectory. Once the robots have been deployed, it's really a matter of can we connect them. The thing that throws fuel on the fire of industrial automation is really a number of technologies that are already on hand. IoT, AI, ML, 3D vision. These are the things that are actually increasing the flexibility of these robots. And as flexibility increases, you're able to repurpose production lines without massive training. Like sometimes it can take 6 months of training to re-engineer a production line. If anybody remembers, during the COVID outbreak, everybody was trying to make N95 masks. It takes a while to retool in order to produce something like a widget that's completely different than what you currently have rushing through your factories. And that's because you have to re-estimate, you have to replan, you have to retrain. There's a number of real life friction points before you can get to the production yields. Was AI, ML, robotic vision, a lot of these robots are becoming much more adaptable. There's new companies that are coming out that are exclusively focused on taking brownfield robots and effectively making them more flexible. That's so that's a key part. Is as flexibility increases, you're going to see more and more of an advantage in terms of high mix, low production volume types of components that kind of cater towards the customization. You're also going to see an ability to be able to kind of stamp out localized production, which particularly, in the geopolitical space that we have today, a lot of sovereign means of delivery is starting to become important for certain nation states. And you are seeing a trend where nearshoring and onshoring is becoming a real thing. That's really being catapulted by the ability to do this level of automation with technologies like AI and ML. The other big thing is the precision is increasing.
Sorry to interrupt, Vish. If you could just wrap up, please. We're just coming up on time.
Yeah.
Thanks.
Absolutely. Great. Well, let me just park with that one then, and go to the next slide, just on planetary connectivity, and maybe I'll end on this. So a lot of the NTN, kind of the announcements are starting to hit the headlines. Many people would have heard about the T-Mobile and SpaceX opportunity that was recently announced. AT&T and Vodafone. I've been working with AST Space Mobile. The difference between prior generations of integration with satellite systems is this is direct to device, meaning you don't need a specialized satellite terminal to relay the downlink and uplink to the satellite. You can use your smartphone. Now, there are some new technologies that have occurred in order to do that. Most prominently is the LEO, but you've got large aperture antennas that can do miracles in terms of receiving at low noise power. But it's really the fact that a lot of the silicon now supports this within the handsets that's driving it. And so what will happen is we are kind of expecting that within the next, kind of 4 or 5 years, you're going to get these new opportunities for what I will call geographic coverage versus population coverage. And that really opens up things like digital divide, autonomous driving for connected cars, remote edge data centers. A lot of that infrastructure is going to be ushered in on the back of this planetary connectivity. So those were the three. The last two slides really is a bit of an edge reality check. I can maybe flip to the very last slide of the deck, Alan. And that one just shows, kind of a view on gaming response times and AR/VR latency. Certainly we are seeing some good response times with the advent of edge, but this is a metro edge. It's hosted, maybe more likely around 8 to 12 hops away from the user. What we're finding is that the actual limitation is in the hardware acceleration on some of those edge nodes. The round trip time is staggering. We are definitely seeing response times that are close to AR/VR latency needs, which is somewhere around 10 milliseconds. But the issue here is that there are technologies that are just not in places yet. So the most staggering result from the round trip time measurements is the one around 5G, which is not much better than Wi-Fi. And the reason for that is because 5G is using a RAN protocol that gets tunneled through to the packet core, and most of the systems haven't implemented something called local breakout. So there's a lot of technologies that need to be deployed for these things to really take hold. We are seeing good network jitter, but there's reasons to believe that both AR, VR in gaming could be a reality if the density and the plumbing for these edge nodes become a reality. And certainly that's just a function of time. So I would submit these are the three that I would look at and definitely expect during the deployment phase for 5G, but we're not there yet. So I'll park it for there, Ellen, and turn it over to you.
That was excellent. Thank you so much, Vish. That was very instructive, and I could talk to you for quite a while, especially around the neutral host. About 5 years ago, we had Capgemini presenting on how they could be a neutral host for their large enterprise customers. And for them, the big problem was it's a small margin business compared to where they make their money.
That's right. That's exactly right.
But anyway, because of time, I just wanted to say thank you. That was excellent. Let's give Vish a round of applause, please.
Thanks, everyone.